Alrighty, so let's start. Remember what we were dealing in our previous classes. So basically, now we are dealing with the firm's problem, right? So you guys told me that hocam, firm's original problem is to basically maximize profits. And then you said that hocam, profit is basically total revenue minus total cost. So total revenue is going to be price times quantity. But we said that how this price is determined or how this quantity is determined is actually a problem, right? So another problem, actually it's not a serious problem, it's something that we can solve. But we said that this part depends heavily on the market structure, right? So whether there are many firms, whether there are only, like a single firm, or there are like 3 big firms. So this part, how they play this game, right? It depends. So we said that this part is going to depend heavily on the market structure. And then on the total cost part, this is also a function of the quantity, but basically, so total cost is if you have 2 inputs. You said that, hocam, you can write this as, right, wage times L, R times K. And then we said that let's just postpone how the decision, dealing with the decision, how the firm is deciding on its output, right? And then let's focus on the problem. Suppose they decide to produce some level of Q0 or Q bar or some level of Q, okay? And what is the minimal cost to achieve that level Q0, okay? Suppose the firm Arçelik would like to, or Starbucks, whatever, would like to produce Q0 units of output. So what is actually, in order to produce Q0 level of output, what is the minimum possible cost, right? So basically we said that this is the cost minimization problem. So we're going to actually get a total cost function, which is going to give us the minimal cost at each possible quantity, okay? And then you'll see later we're going to use that total cost function because remember, we don't have to deal with the market structure. We don't have to deal with the case that whether, like the Mozart Cafe downstairs is the only cafe on campus, or it's one of the 100 cafes on campus, or it's one of the 2 cafes on campus, okay? We don't have to deal with that for the cost part. All we have to deal with is that, okay, for any given level of quantity, and suppose we're giving the wage level and the rental level, right? What is the cost function? We can get the cost function, and it's going to give us the minimal possible cost at that level of, if you want to produce that unit of output, okay? So basically, we were dealing how to get this cost function, and we did, right? And then we were trying to, you would like to produce this Q0 level, but you want to do this at a minimum cost. And then remember from here, we got the total cost function, which was a function of what? W, right? The input prices and of course the quantity that you would like to produce, right? Q0, or if you want, I can get rid of this. For any level of Q, this is going to give you the total cost, right? Now, so today we'll come to this part, okay? So we're getting closer because we're almost done with the cost functions. But today I'm going to draw you some graphs, okay, which will help us to understand what's going on. Now, remember, so this is what we did, and then we said something. So what is this total cost function is, remember when I draw it, I said that it doesn't matter, for instance, if there's constant returns to scale, I have something like this, right? How was it, the total cost function, when we had constant returns to scale? It was linear, right? It was something like this, so it was something like this, right? And then if there is, like the other returns to scale phenomena, you have increasing returns to scale, decreasing returns to scale. We can have, mostly we said that, so this was constant returns to scale, but mostly we would have cost function like this, right? Initially, so we have this, and we might have some flat part, and it might go like this, okay? And then here we said we had what? This is increasing returns to scale. You can always think of it like this. Here the costs are increasing, but at a decreasing rate, which is good, right? So increasing returns to scale was also a phenomena which was good, right? And then this, if there's this sort of this linear portion, you can call in this portion we have constant returns to scale, and then in this portion you can say that we have decreasing return scale, right? So you see that costs are increasing at an increasing rate, right? As you increase quantity, costs are increasing at an increasing rate, okay? Now, we said this, but then we said that these total cost functions are starting at which point? At the origin, right? So they start here. Why?
Labor and capital are fixed, not fixed.
They're not fixed, right? So I can change anything. So this cost function that we have found from, our cost minimization problem is, we said, is a long run cost function, right? So this guy, it belongs to the long run. Then we said that, well, but it's very important for a firm to distinguish between short run and long run. We'll see. So, and then we said that, well, so let's actually say this short run costs versus long run costs. And then we said that, well, it doesn't matter whether the short run or long run, we cannot, how shall I say, we cannot say, like 1 month is a short run and 6 months is long run. It depends, right? It depends on the situation. So suppose if you would like to generate electricity, you would like to build a dam, then even 1 year might be short run, right? You might not be able to build a dam. You know what a dam is, right? So it might be really hard, right? So the long run might be 5 years. I don't know. So it depends on the situation, right? The firm. So it could be, or, for Mozart Cafe, the long run might be 3 months, okay? So, but we said that we don't have a time period, fixed time period, but how we understood this is that we said that short run is a time period where firm cannot change some of its inputs, right? Some stuff are fixed. Firm is not fully flexible. And then we said that in the long run, we assume that the firm is fully flexible. So here, firm can decide on both capital and labor. But in the short run, we said that firm cannot decide on both labor and capital. And usually we assume capital is fixed, okay? And then we said that short run total cost is a function of what? So it's going to be a function of Q. Yes, it's going to be a function of W, R, and we said that fixed capital, right? If you assume that capital is fixed, then the short run total cost is going to be a function like this. So it's basically wage times L, R times K, but this time K is fixed, right? And then we said that, well, this is the case, and we call this is the fixed cost, right? And we called it variable cost. Short run variable cost or short run fixed cost, but fixed cost is a short run phenomena, okay? Now, so this is basically what we said, and then we said something. I asked you, remember I said that, do you think that this short run total cost can ever be above the long run total cost? What did we say? Remember? So what about this? This short run total cost, suppose I draw this curve, and at this level of K bar, and then I draw my long run total cost curve. Do you think what is the relationship between these guys, or total cost? So do you think this is less than this guy? Short run total cost is, right? So you told me that, hocam, they are going to be equal to each other when? If K bar is the optimal, right? So suppose you would like to produce some level Q, let's say Q bar. If this K bar is the optimal level of capital, right, that you would find from the cost minimization problem, and you happen to pick that K for the short run total cost, they're going to be equal to each other, but at what point?
And the K is equal.
They're going to be equal to each other at which point?
When the K is equal in both of them.
So we said that we said that, okay, K bar is just, but at which point there? So these would be functions of Q. So think of it. Suppose I gave you these guys, okay? I gave you this, I gave you this. So this is a function of Q, and this is an K bar. And we know that this is a function of Q. So suppose I also gave you the K bar. So these guys would be equal to each other when? At which quantity? It's not hard. It's not a tricky question. Okay, so let's do it here. So now I'm going to draw you these curves, okay? So let's do this. So this is total cost. This is Q. So this is total cost, okay? And then, so this is the case for the, it doesn't matter. I can also draw it for a more generic total cost function. So which is this, okay? So suppose this is a more generic total cost function. Now these guys, if I want to draw my short run total cost curves, how shall I draw them? So first of all, do you think they would start from here? No, right? So they should, why? They won't start because of the fixed cost, right? So they should start from somewhere here. We don't know, depending on that, right? And then how do you think they should look like? So let's put it like this. Suppose you would like to produce Q0 units. Total cost is giving you the minimal possible cost, right? If you want to produce Q0 units, given wage and R, this is the minimal possible cost, okay? So then suppose, and in order to produce Q0 units, let's put it like this. So suppose to produce Q0, optimal amount of labor and capital is this. Suppose, okay, to produce Q0, optimal capital and amount of capital and labor is this. How shall I draw my short-run total cost curve? Do you think it should be linear? Do you think it can cut like this? Yes, no, maybe, no. Okay, so it would look something like this. Okay, so let's start from here. Okay, so it's gonna be something like that. Okay, so it's going to be tangent to the total long run total cost curve at that Q0 point. Then what should I write for this guy? Short run total cost curve, but at what point? So this is, suppose I would like to write down the capital amount there. What should I write? K0, right? So we can write these short-run total cost curves. So suppose, for instance, you would like to produce Q1 units, okay? And suppose in order to produce Q1 units, optimal amount is L1, K1, okay? Then you have a short run, obviously, and suppose K0 is less than K1. Of course, your fixed cost would be higher, right? So you would start, so you can actually put here R times K0, R times K1, right? These are the fixed costs. And then here you can actually have something like, and then from here it's going to be tangent, and it's going to go up, okay? Short run total cost K1, okay? This is not linear, so just have it a little bit curved like this. Okay? So you see, this is how we are going to draw them. So, but then what's happening here? What's happening here? What's happening to the costs? Short-run total costs. They are, as quantity increases, they are increasing, obviously. But are they increasing at an increasing or a decreasing rate? Decreasing. Why do you think the costs they're getting higher and higher, but they're getting higher and higher at a decreasing rate? Why? And here, when you move away from this point, they're increasing at a increasing rate. Why?
Because until
Right? Because you're moving away from the optimum, right? You're moving away from the optimal level. Here, you're getting closer to the optimal level, so it's good. Before you had, as you said, Hocam, too much capital, too little labor. Here, you keep increasing because it's short run. The only way you can increase your output is that you increase your labor. So you keep increasing your labor, your costs are increasing, but now you get to use that a lot of capital, right? So which is good. Now you can use it. Now you have more workers which can operate. Suppose you had 50 computers, but you only had 2 workers, right? So 48 computers were useless. Now you get more and more labor. They can make use of that bulk of capital there, right? So when you come closer to the optimal point, costs are increasing, but they're increasing at a decreasing rate. Now you move away from the optimum, so they're increasing at an increasing rate because now you're moving away from the optimum, right? Capital is becoming too little. If you increase, it's becoming even much more less, right? Than before, than the optimal amount, okay? So you see all these in this course, as we always do, we can always explain the shape, the curve, the curvatures and everything of these curves, okay? And that is the reason behind, because you are moving away from the optimum, okay? So that's why here the costs are increasing at an increasing rate, here costs are increasing at a decreasing rate, okay? So this is basically the case. And you see, suppose I have a level of Q bar here. Suppose I have a level of Q bar, okay? So this Q bar level is, if I want to produce this Q bar level, you see, with this amount of capital, let's say K0 amount of capital, if you want, I can put these guys, right? So then I'm going to be here. You see, what does this tell me? It tells me that when you would like to produce Q bar units of capital, Q bar units of output, the minimal cost you can achieve is this much, right? But if you insist on producing it with your K0 level, your costs would be much higher, okay? So just keep this in your mind that, oh, these short-run total cost curves are something like this, and they touch the total cost curve just at the point where that capital is maximum. That capital amount is actually the optimal amount for that level of output, okay? Only at that point. Any other point, it's going to be above or below. The short-run total cost curves will be above, okay? So it doesn't matter, it's the same phenomena. If you have a total cost curve like this, you would have still very much the same, you know, like those cost curves. You would have them like this and then like this. Suppose short-run total cost K0, so I put it Q0 here, okay? And then it would be again short-run total cost K1. Then at this point, this should be Q1, and K1 should be the optimal amount of capital in the long run, right? To produce Q1 units of output, K0 should be the optimal amount of capital in order to produce Q0 level of output, okay? So that should be, so if you don't want the constant returns to scale case, you see it's the same idea. That's why we call these we call the long run total cost curve an envelope of the short run total cost curves, okay? That's why, because it covers them like an envelope, right? So that's why basically we call, so let me write this down. So long run total cost curve is an envelope of short run total cost curves. Okay? Cost curves. Okay? So that's why it's called an envelope, because the short run total cost curves are always above, right? And they're touching at their they're touching the long run total cost curve, but long run total cost curve is the minimal possible cost you can achieve, so that's why it's always going to be lower than that. Okay? So this is basically the case. Now, so let's actually try to have the
Ya burada return to scale derken production anlamında için cost function anlamında.
So it's this is what we said actually in our previous class. So when we think of, remember the cost function was coming from where? Cost function, so cost minimization problem is what? Minimize, right? So you said cost, total cost. So L, K, you put here, right? Wage times L, R times K. Subject to, we actually said what? What is it? Suppose you want to produce Q bar or Q0 unit. Subject to. So you want to minimize your cost, but you want to produce, right, some amount. Basically, let's put it Q0 or Q bar, okay? So returns to scale, so Jim is asking, Hocam, returns to scale was a phenomena which was related to the production function, right? That's what we said. But you see, bless you. But we said that it was related to this, but when we get this total cost function, right? So we solve this problem, we get the optimal amount of, right, these conditional demands for capital and labor, right? And then we plug them back into this function here, our objective function, and we get the cost function, right? That's how we get the cost function. That's why this phenomena that we observe here is going to be embedded in the cost function as well, okay?
Q dediğimiz şey return oluyor.
Returns to scale means that if you would like to increase your quantity, so let's say, right, so whether we can ask it like this, should you use twice as much as capital and labor or less, okay? It depends, this determines if you would like to double this, whether you need to use double the amount of labor and capital, which would mean that whether your cost would double or not, right? So given a wage level and rental rate level, right? So that's why returns to scale is a phenomena that we said about the about the production function, but it will be, when you solve this cost minimization problem, it will be embedded, you can see it in your cost function as well, okay? So this is basically, so that's what we said before. So that's why we can actually observe the returns to scale phenomena also on the cost function. I think it was here as well, okay? And by the way, you should be careful that there are these are two different concepts, okay? So let me actually mention it. So returns to scale, so let's call it returns to scale, okay? Versus diminishing returns. So, or let's put it law of diminishing returns. Do you remember what these are? Returns to scale, you know, right? Oh, hocam, if you double all your inputs, what is basically what's going to happen to your output, right? Returns to scale is a phenomena like that. So do you think returns to scale is a long run phenomena or short run phenomena? Long run, right? So that's why, so this is actually a concept that belongs to the long run, right? Because only in the long run I can say that I'm doubling all my inputs, right? I'm actually increasing all my inputs. Otherwise I cannot say it. But what was law of diminishing returns? Do you remember the diminishing returns phenomena? What was it?
If you take one of those inputs constant.
Right, so suppose, remember what did we said? We talked about Malthus and such. So we had a fixed amount of land And if people keep, like if the population is getting larger and larger, right? You keep adding more people to the land, let's say, right? At some point, what was going to happen to their productivity, marginal product of labor? It was going to fall, right? So in order to think of the diminishing returns concept, you have to have a fixed input, right? So that's why this belongs to Shortrun, right? So usually, but of course, it's very hard because if I want to show you the total product curve, and I want to show you returns to scale, I have to draw you a 3D diagram, okay? So which is hard, so that's why we try to show, in order to show things on a two-dimensional, graph, then we have to, either, we can only have, for instance, labor as an input, right? If you want to show the total product curve, but then you can only show it in the short run, okay? So just keep this in your mind, just a quick reminder, okay? But now let's actually try to have the same stuff for the average and marginal cost curves, okay? So this is going to be a little bit of an ugly graph, but hopefully it won't be. But it's going to show us an important phenomena. So we'll see. Now I'm going to define, before I draw them, I'm going to define, so let me write it here. The short run average cost and the short run marginal cost curves, okay? So now let's actually have that. So we're going to have the short run and long run curves. Okay, and let me define these. Short run average cost curve. Okay, so this is going to be short run total cost curve divided by Q. So basically, remember we said that short run total cost curve is a function of wage RQ K bar divided by Q. Okay, and the short run marginal cost curve, it's going to be the derivative of the short run total cost curve with respect to Q. So this is going to be short run total cost curve wage RQ K bar del Q. Okay? So this is basically, like how we define them. You guys could guess, right? So basically now let me draw the relationship. Here I drew the relationship between the total cost curve and the short run total cost curve. Now let me draw the relationship between the long run average cost, long run marginal cost curves, and the short run average cost and short run marginal cost curves, okay? So now let's do that. So we're going to have this graph. Again, it's not going to be very pleasant, but let's see how we can do stuff. Let's see. Oh, this is okay. So I'm going to have long run average cost, long run marginal cost, short run average cost, and short run marginal cost curves here. Okay? And I'm going to have the quantity level here. So let me first draw the long run one. Okay? So I'm going to have something like this long run average cost curve. And for, again, coming back to the returns to scale issue, this is the long run average cost curve. And if I want to talk about the returns to scale, what should I say? What do I see here? So let me draw it here. Long run average cost, I have Q here. I have something like this and something like this, long run average cost curve. So what do I have here in this portion? Increasing returns to scale, right? Always think of it, when quantity increases, of course costs will increase. But per unit costs are actually decreasing, which means that I'm doubling, suppose, all my inputs. My output is actually increasing more than double. That's why my average costs are actually falling, right? So that's why here we're going to have increasing returns to scale. In this flat portion, we have constant returns to scale. And in this portion, we have decreasing returns to scale, right? You grow, you expand as a firm, your average costs are increasing, okay, which is not something good. So that's why, remember, we said that it's very important to figure out where you are on your cost curves, right? So this is the case. Now, suppose I would like to draw my marginal cost curve. Where should I draw it? Suppose I have my long-run marginal cost curve. Where should it pass? The marginal cost curve was cutting average cost curve where? The minimum, right? So here it's a little bit, we have this flat portion, but suppose it had like one minimum, so it's going to pass through the minimum, right? So that's what we said. So if I want to draw my marginal cost curve, I should draw it something like this, okay? So this I know. This point I know, let's call it Q1, okay? Now, so just to be proper, let me actually draw it like this, okay? So I draw the flat portion just to show you guys, but now I'm going to have, so that it would have one minimum, okay? The minimum is unique. Okay? So let's have it like this, okay? Now you guys know that, oh hocam, in this portion there is increasing returns to scale, in this portion there is decreasing returns to scale, okay? Now let me draw my short-run curves, okay? So I'm going to draw my short-run average cost curve like this. This is short-run average cost, and then I'm going to, let me call this Q0, okay? I'll call this point A. So this is Q0, and then I'm going to call this short-run average cost K0. You know what I mean by K0, right? K0 is the optimal amount of capital in order to produce Q0 units, right? Now, but why did I draw it like this? Why did I draw the short-run average cost curve like that? Why? You see, it touches, but it touches at this point, right? It doesn't touch at the minimum, for instance. Why? Capital is fixed would be at other points as well. So for instance, this short-run average cost curve would be touching this guy at its minimum.
Because it will require some amount of time to reach the minimum point for the long run.
So usually in these, like the answer for most of my questions is returns to scale, okay? So you see that here you guys told me that, hocam, in this portion we have increasing returns to scale, right? So it turns out that apparently due to increasing returns to scale, even, this at this K0, if you have a fixed amount of capital, right, K0, and it's just enough, so it's the just right amount of capital, right, the optimal amount of capital in order to produce Q0, okay? Now, but then, because there is increasing returns to scale, you can, as output increases, let's say it comes to a point like this, let's say it's here, okay, somewhere here, let's call it Q1 or Q bar, okay? You see that actually costs can increase even a little bit further, okay? In the short run, if you look at your short run average cost curve, okay? So they can go, because there's increasing returns to scale, you can go even a little bit lower cost, lower average costs. But is this the optimal amount in order to produce Q bar level of output? Is that the minimal cost in order to produce Q bar level of output? No, right? You say that, hocam, fine. in the short run, let's say this is Arçelik or, you know, like Intel or Toyota, whatever, or Starbucks. So let's say it's Toyota, so they can actually go a little bit further down in their average cost curve if they have a fixed amount of capital, let's say K0. But in order to produce Q bar, they can do, if they can change the capital amount and reach the lowest possible cost, they can do much better, right? They could have achieved a much lower cost with a new amount of capital, of course. But if they insist on, oh no, we have this fixed amount of K0, then they can be here, okay? So the reason why on the increasing returns to scale portion, the short run average cost curve is touching, you know, like the long run average cost curve at this point is due to, because there's increasing returns to scale, okay? So the reason is basically that. Now, and then at this point, so let me write this down, otherwise you won't, so that you would have nice notes, okay? So let's say this, suppose, or let me write it with this one. Suppose, let's say to produce Q0, okay? So we know that K0 is the optimal amount, okay? So K0 is the optimal amount of capital, right, in the long run. So this is what we said, fine. So then this is the short run average cost curve that we draw, okay? So, but we said that it's going to be tangent to this guy at this point because there is increasing returns to scale, okay? So it will short run average cost curve, so K0 will be tangent to long run average cost curve at Q0. That we know, right? So they will be tangent to each other at that Q0 level, okay? And it's not going to be, so let me just say this, but it's going to touch the Q0, short run average cost curve is going to be tangent at a point where basically so it's going to be tangent at a point which is on this portion of the curve, okay? It's not going to be at its minimum due to returns to scale, okay? So you can say that due to increasing returns to scale, short run average cost K0 will be tangent to long run average cost, okay? So we can actually say at its decreasing portion, okay? Because there's the increasing returns to scale, okay? So that's why it's going to touch it at that portion, okay? Now, did you get this? It's clear, right? Now, if I want to draw the marginal cost curve, let's do this and then we'll give a break, okay? So if I want to basically draw the marginal cost, what should I do? If I want to draw the marginal cost curve. So this is the short-run average cost. We know that the short-run marginal cost is the derivative, whatever. But the short-run average cost curve, what about the short-run marginal cost curve? Where do you think it will pass?
It will pass through that the tangent point.
Okay, so you actually know two things about the marginal cost curve. First, marginal cost is going to pass through where? The minimum of average cost, right? So that, you said that, okay, it has to go through here, right? And also it should pass through where? You see, it's a graph, but like we're not just drawing it. Like there are like all these points, they have a meaning, right? So we are going to draw this curve, taking those facts into account. So first you said that, hocam, it's going to pass through here, the minimum of the average curve, okay? And then it should pass also So with the same phenomena, if these guys are equal to each other at Q0, right? Then when I take the derivatives of both of those guys, they should also be equal to each other, right? So then it should pass through where? So the long-run marginal cost, so the short-run marginal cost should also be equal to the long-run marginal cost at Q0, right? So it should pass through this minimum point, okay? So let me draw it. So it's something like this. So let's have it. Okay, so this is short-run marginal cost K0. Is this clear? So you see that it has to go through, right, the minimum of the average cost curve, but we also know that they should be equal to each other at, again, Q0, okay? So let me write this. So it will be tangent to long run, and from here, also short-run marginal cost K0 will be equal to, or we can say since or hence, will be equal to long-run marginal cost at Q0, okay? So this is the case. Now we'll actually try to figure out what's going to happen for this guy and also on the decreasing returns to scale portion. Okay, so let's give a break and then we'll continue.